Okay, so in this problem, we're asked to to graph the function g of x and the function is log base 2 of x minus 2 minus 1. So to be able to find, there are many different ways that you can graph a log function, but since I don't really like to remember a lot of things, I think the easiest way for me is that I know how to graph an exponential function. Therefore, I know how to draw how to graph the logarithmic function, since the logarithmic function is the inverse of an exponential function. So I would start by looking at since we have base 2, right? So the inverse of that would basically say that it is an exponential function of base 2. So we have 2 to the x. And right now I'm not really thinking about any of the shifts or anything like that, so I'm just going to say that I'm going to graph this function right here, okay, f of x. So if I graph these functions, I know that for an exponential function, something that I always want to be able to graph are the points. So for -1, you have, it's 1 over the base, which is 1 over 2, 0, the input is 0, the output is always 1, and when the input is 1, the output is always the base, so equals to 2. So if you remember in class we did this, so -1 is 1 over a, 0 is always 1, and when the input is 1, the output is always 1, it's just a. So if I were to plot those points, so I have -1 equals 0.5, 0 is 1, 1 is 2, right? So my exponential function is roughly going to look like that. Now when I look at this, the domain for this function right here, for the exponential function, is from -infinity to +infinity, and the range is from 0 to infinity, and the asymptote right here, right, the asymptote is at y equals to 0. So one of the things that we talked about is that if they are inverse functions of each other, some points that we're going to have, I'm going to change the color for that, so let me do it in purple. So if I have a function, that is x, and I'm just going to graph the function log base 2 of x. So if I were to graph this, I'm just going to say that there is a function. This function is going to have the following points, right? 1/2 is going to give me -1, 1 is going to give me 0, and 2 is going to give me 1. Also, the domain is going to be 0 to infinity, and the range is going to be -infinity to +infinity, and the asymptote it's going to be x equals to 0. Now we also have to at this point take care of the translations that we've been asked to do. So for that, I don't think I left enough space, so what I want to do is I'm just going to move a few things around. Okay, so let me just move this a little bit to the side. How do I move this? Let me just try this again. I'm going to copy this, and how do I move this? Okay, there we go. That's not what I wanted to do. Alright, let me just erase this part right here. I just wanted to make a little bit of space. Okay, so in this function, just like we've been doing before, whenever we graph, we want to look at, let me just find a color, maybe not the best color, let's go for black. So in this function right here, we have to be able to recognize, right, that there is an horizontal translation. So it's a horizontal translation, and a horizontal translation is going to affect my x-axis values. So I'm going to move 2 units to the right. So 2 units to the right, that means that I'm going to have to add 2 to each point, 2 to each point. So now I have 2.5 is going to be my new x value. 3 is going to be my other value. 4 is going to be my other value. Now, also, what we have to take into consideration next is the minus 1. The minus 1 indicates that we have a vertical translation, and a vertical translation affects our y value. Since it's minus 1, that means that I'm going to move 1 unit down, so I'm going to have to move everything 1 unit down. So I have minus 1, minus 1, minus 1, so minus 1, negative 1 minus 1 is negative 2, 0 minus 1 is negative 1, 1 minus 1 is 0. So now what we've done right here is we've taken care of our translations, and now we have the points necessary to be able to graph the function log of base 2 of argument x minus 2 minus 1. So let's plot the points. So, and the points that I want to plot are these ones right here. So the points are 2.5 input gives me a negative 2 output, 3 input gives me negative 1 output, and 4 gives me 0 of an output. So let's try it right here. So I don't think I left enough space, but we'll manage. So 2.5 right here, right? 2.5 is right here. That is going to be equal to negative 2, so 2.5. So this is 3, this is 4, and I really ran out of space. Okay, this is going to be a little bit messy. So then we have 3 is negative 1, so 3 is right here, 3 negative 1, this point is right here, the other point is 4, 0, right? But we have to take into consideration that since we have here minus 2, the asymptote has also been moved 2 to the right. So the asymptote for our shifted function is going to be x equals to 2. So we'll look at it right here. This is where the asymptote of the logarithmic function is going to be. And the function is roughly going to look like that. And as you can see, the domain of this specific function is, so the domain is from 2 to infinity, and the range is from negative infinity to infinity. And that's how we graph a logarithmic function. If you can recall what how to graph an exponential function, and how and if you can remember that a logarithmic function is the inverse of an exponential function.